All right, hello once again. Jeff Scott, formerly of Rankin Technical College, and as part of my YouTube channel, you can see the YouTube address up on the top there, JPS-Jeff Teaches Programming, which right now has one playlist in it, which is Jeff Teaches Programming-Python. I've been going over the Python programming language, kind of, for lack of better words, learning it along with you. And I talked about beginning Python concepts. We went over the Python keywords. I did a bunch of procedural Python programs. We talked about the main Python data structures, those being lists, dictionaries, tuples, and sets. We went into object-oriented programming in Python, and just recently finished going over some stuff where we did some Python handling text files. The next natural step, in my opinion, is to go over databases. Now, two things I want to show you in here. First, and this is something that I went over a long time ago, but I found an article online for how to learn Python programming from scratch. All right, and it said here was the structured approach. Introduction to Python. You know, I had somebody comment on one of my videos, and I've seen this before too on articles, that Python is kind of known as a Swiss Army knife. And in other words, it can be used for a lot of different purposes. We went over installing Python. I've chosen one IDE. That was Visual Studio Code. And I've been using that throughout. We went through the syntax. Yeah, we did write basically a hello world program. I went over the Python keywords. We went over the basic data types in Python, how to create variables, basic operators. If you remember, we went through and even created a simple calculator program. All right, control flow. We went over the different types of looping structures. We went over if statements, if elif statements, if else statements, etc. We went over and we've written many functions throughout this course. Then, as I mentioned, we went into some of the core concepts. We went into lists, dictionaries, tuples, and sets. We just did file I/O. We've been doing exception handling throughout almost the entire course. Now, I haven't really gone into this as far as how to import and use external libraries, except, yeah, we kind of have. We've imported our own stuff. We've imported things like random for etc., etc. All right. We've gone over object-oriented programming. Some of the stuff that's in here, like map, filter, and reduce, I believe we're going to spend more time on that. But we'll spend more time on that when we get into basically writing the equivalent of websites using Python. Same with regular expressions. All right. Same with web development. Now, my hope is eventually when I get done with this, and I've made about 45 or so videos, that'll be maybe even double that. But next, I'd like to get into data science, talk about some of the stuff that's shown here. All right. And yeah, that won't be free. I don't know how much I charge for something like that, but I'd put that out there and make it available to people for hopefully a very nominal price. Automation, well, we've looked a little bit about that, but not a lot. We will go into APIs. All right. Now, the coding challenges have been things that I have done. All right. We built projects. Yeah, we did a simple calculator. We could do a to-do list. Maybe we will. We will create a personal website. So we've done a lot of these things that are in here, is what I'm trying to tell you. All right. But now that we're moving into the realm of databases, I showed this last time, but I've added to it. I'm going to go over 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Looks like 6 different articles. For now, I'm going to spend the majority of the rest of this lecture on these 2 articles. Understanding Relational Databases, a Beginner's Guide, and what is RDBMS, which again, as you can see, is an acronym for Relational Database Management System. Now, Python works, you can get it to work with basically any RDBMS. All right? And the only, we'll talk a little bit in here about SQLite with Python. Later, we'll talk about MySQL with Python. But you can use Python with SQL Server, which is a Microsoft product, Oracle, and Oracle owns also MySQL. All right? But we're going to talk about all of this stuff. All right? But like I said, I'd like to more concentrate on this for right now. And before we even get into this, I'm going to give you some definitions. So these are my definitions. I'm not claiming they're the best. I'm not claiming a darn thing. But I want to talk about a few things, such as what is a character? What is a field? All right? What is a record? What is a table? What is a database? A couple more. What is a primary key? All right? And we'll start there. Okay? I look at a character as basically anything on the keyboard. All right? Yeah, there might be other characters that are not on the keyboard. Back in the day when I started to learn this stuff, all right, everything was basically national, not international like it is right now. And if I go out over here and I type in this, so I'm going to go in here and I'm going to type in, let's go into Google Images. All right, and I'm going to type in here, ASCII table. Okay, all right, and you can see this, very hard, kind of hard to read, but I'll grab one of these. And we'll try to make it bigger. And what you'll see on here is 127 different characters. And if I go down a little further, well, there's 127, and there's 128. All right? Back in the day, like I said, when I was learning this stuff, all right, we learned ASCII, American Standard Code for Information Interchange. And at that time, basically, everything you did was on your keyboard or whatever, but it was basically made for English. I remember many, many years ago when I was still teaching, many years ago, I was teaching in Wisconsin, and I took the students to a computer show at McCormick Place in Chicago. And while we were there, it was kind of interesting. It doesn't seem like that much right now, but back then, I mean, this was probably, could have been 30 years ago, right? Could have been even more than that. I don't know. But what I was doing, what I did at that time, all right, was we went and we were looking, going through the different vendor exhibits and the like. And there was a guy there, and he said, "Oh, everybody come over here. I want to show you this demo." Okay, fine. So we're walking by, and what it was a guy, an American, and he had next to him a guy who was from Japan. All right. And both of them, each of them had a computer, and they had big screens that they were showing it on. And the American guy would type something in like, "Hello there, how are you?" And on the other end, it would come out the Japanese version of "Hello, how are you?" And they were conversing back and forth as though you and I were sending text messages or whatever, but in the same language. All right. And the reason I'm telling you that is over time, we've changed from this ASCII, American Standard Code for Information Interchange, with about 128 characters. We've gone over, all right, and we don't use, I mean, is that still used? Yes. All right, but if I type in here, computer character set, all right, and if we come in here, it says, what is a character set? It says it's the complete set of characters and they're number codes that can be recognized by a computer. Okay, I'd agree with that. But what's happened over time is now, rather than just there being ASCII, we've got something that's called Unicode. All right? And the difference is, whereas ASCII displays 255 different characters, the last time I heard, and this could be wrong, I don't know, but the last time I heard, the Unicode character set has over 100,000 different characters. The first 255 characters out of those 100,000 plus are the ASCII character set. All right? But what I'm trying to get across to you, I'm not trying to waste your time, but basically when I look at characters, they are what's on your keyboard. Yeah, there might be other things. All right? So what's a field? A field is one or more related characters. Now, it can be as small as one character. You've got a field that's called middle name. All right? Or I'm sorry, try it again. Middle initial. That'd be one character. Then we get a record. What's a record? One or more related fields. All right, then what's a table? One or more related records. What's a database? One or more related tables. Finally, what's a primary key? It's a unique record identifier. Now, you're going to see these same things that I just put on here. You're going to see these in a couple of these articles that we're going to start going through in a minute. But imagine that I wanted to create a table. All right? And I wanted to put, let's say, the names of my family in there. Okay? So let's say that I set it up so for each member of my family, I want their first name, followed by their middle initial, followed by their last name, followed by, let's say, their address, their city, their state, their zip code, and their phone number. All right? So, for instance, for me, and you're not going to, of course, get all my info, but I'd have Jeff. How about we'll put the complete name? Jeffrey P. Scott. All right, I'll put my old address down from where I used to work, which was 755 Parr Road. And that was in the city of Wentzville, the state of Missouri. The zip code was or is 63367, and the phone number is or was 314-286-3675. I have absolutely no idea what would happen if you call that number today. None. All right. So what is this? This would be a record of information. That record would hold 1, 2, 3, 4, 5, 6, 7, 8 fields. 1, 2, 3, 4, 5, 6, 7, 8. Each one of these fields is made up of one or more characters. So again, a field is one or more related characters. All right. A record is one or more related fields. So this would be a record. If I put the information down, all right, and let's just say it's my wife. We'll just use, I won't even put down her married name, but All right. Again, those aren't the right addresses for everybody. I'm sure you, or hopefully you get that. All right. But what do we have here? We've got 5 records. Each one of the 5 records contains 8 fields. Each one of the 8 fields contains one or more related characters. All right. So I could make this into a table. Maybe I'd call it family members. Then maybe I'd create another table that I call friends as an example. All right. And I could put those into a database. Now, the only thing I haven't mentioned from this list here is a primary key. Now, in this case, you can use your first name. No. A lot of people think, so this is not my social security number, but if I put down 111-11-22-3333, that, yeah, social security number would be a great primary key. Oops. So I could put, come on, Jeff. So I could put, as an example, all right. No, we don't all have the same social security number. I mean, that would be kind of ridiculous. But let's just come in here and put this. So say we had something like this. All right. Now we have a primary key because each one of these is unique. But what you should do, not everybody does this, but what you should do is not only should this be a unique record identifier, it should be an unintelligible unique record identifier. And what does the word unintelligible mean? Well, think about it this way. If somebody finds my social security number and uses it, they can do things with it. Not nice things, but they can do things with it. But if I change this and I add in here, so let's say that this is field 1, oops, that this is we'll call it an ID for identifier. This is ID 1, this is ID 2, this is ID 3, ID 4, and ID 5, like that. Now, if I do that, I'm going to make this so it lines up a little bit nicer. It looks a little better, I think. All right. Yeah, that looks pretty nice. All right. This is unintelligible right there, because if somebody gets a hold of that field, which I just will call ID, there's not much they can do with it. But in here, so I'm going to add here an ID and an SSN. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 fields. All right. So I have characters on the keyboard that I'm putting together to make a field. One or more of these fields I'm putting together to make a record. So I have 10 fields in here. I have 5 records in here. I have 1 table in here. Let's just grab a couple of these. And if I come down here, this is going to be a new table. right, and let's say this is Gerald P. Jones. Again, I'm making this up. And it should be Gerald. And let's say that this is, I don't know, Brian L. King. I'm not going to change the addresses or anything. But now I would have two tables. So this first table could be family. That could be the name of it. And the second table could be friends. That could be the name of it. So again, I'm putting together one or more characters. Each time I do that, I'm making a field. Each time I put one or more of these fields together, I'm making a record. Each time I put one or more records together, I'm making a table. Each time I'm putting one or more tables together, I'm making a database. And I just showed you what a primary key is. All right, so that's just kind of an introduction to that. So let's jump into this first article here. Understanding Relational Databases, a Beginner's Guide. There are more databases than just relational databases. I want to say that again. There are different types of databases other than just relational databases. Okay? Now, I'm going to age myself here because when I graduated from high school, yeah, we just had our 50-year high school reunion. But when I graduated from high school, the year that I graduated, we got our first computer into the high school that I worked at. Now, that almost sounds funny today. And that computer had to have been, I don't know, 6 feet wide and probably about 40 feet long. It took 4 or 5 people to pick it up and carry it into the office. I saw them when they were bringing it in. Today, I'm sure that computer had less ability, for example, than what you have today on your phone. So who cares? Why are you telling us this, Jeff? All right. Well, back in that time, in around 1970, there was a mathematician named E.F. Codd who came up with a relational way of thinking. And that was that relational way of thinking, which was basically a lot of mathematical concepts. They were applied to databases. Now, again, who cares? Well, fast forward, we're 50-some, maybe almost 55 years later, and we're still using relational database management systems. Think about where computers have come up to in 55 years. There aren't too many things that have stood the test of time like relational database management systems have. But there are relational database management systems, there's object-oriented database management systems, there's what are called NoSQL database management systems, and there's others. All right, so let's jump into this first article. Righty. So that is here. Understanding Relational Databases, a Beginner's Guide. And it's not real long. Okay. So it's pretty up to date, which I kind of liked about it. June 9th, 2024. So again, this is an author's point of view, so you may not agree with everything that's said here. I may not agree with everything that's said here, but it's fine. They call relational databases the backbone of modern database management systems. Notice, they organize data into tables. That allows, as it says, for efficient storage, retrieval, and manipulation of information. There is a distinction too. Notice data and information. let's add those to our list. Now, I can be a smart aleck here because there are many books and the like that will say, what is data? Data is unprocessed information. And what's information? It's processed data. And I'm not even going to disagree with that. But typically this may or may not make sense to all readers. This should make sense to all readers. And if that confuses you, let's try to put this into context. All right? I know it's not exactly done like this anymore, but let's assume for just a second, I guess we're playing pretend, that what happens at the end of the day in your bank is the teller has got a list of deposits and withdrawals. And basically what they do is they're making two lists, and they record on each list all the deposits made for that day on one list, and on the other list, all the withdrawals that were made on that day. Okay? Well, if their boss walks by and they see this list or these two lists, they may not know what they are, or if they do, they may not know which is deposits, which is withdrawals, etc. Because that's data. But once that data gets fed into a computer and it gets maybe put in as part of a report or whatever, where a manager, for example, can read it, then it becomes information. All right? Each table in a relational database represents a specific entity. It's a thing. It can be a physical thing, or it can be a conceptual thing. Now, notice in here they call the columns. Columns are another word. Get back into here. All right, a field is also known as a column. It's a column of data. Oops. All right, a record is also known as a tuple. All right. So a lot of these go by more than one name. Okay, but this field, this column, all right, and this record, really the field is one or more columns. The records basically make up an entity. It's what you're trying to come up with data about. All right. Then there's attributes or properties of that entity. Think about this. If the entity that I gave you before was family, the properties were first name, middle initial, last name, address, city, state, zip code, etc. And the rows were my family members. All right. So tables are composed of columns. As it says, they're also known as fields. They're also known as attributes. Records are known as tuples. They're also known as rows. All right. Columns, as it says, define different types of information. Rows represent individual instances. That's what I just showed you. Now, they give an example here of a customers table, and they say it might include things like customer ID. See, I could change mine from ID to like family ID, and my friend went to friend ID or something like that. What I did was, rather than have a name, I broke it down into first name and last name. Customer, you probably would want to do the same thing. I didn't add email. All right, so there's more we could have put in here. Now, if you look here, there's introduction, table structures, boom. We're up to number 3 here, primary keys. Again, notice what they say. A primary key is a unique identifier for each record in a table. If you remember, the first thing that I put in here when I was defining that was I said unique record identifier. As it says, its job is to ensure that each row within the table can be uniquely identified. Primary keys are usually one column, if possible. Sometimes they're made up of multiple columns. All right. You also have something that's called a foreign key. All right, we didn't add that one to our list. Let's put it in there right now. So you got a primary key, and let's have also in here a foreign key. Now, I didn't do this, but I'm going to make a change here. Okay, so let me do it. There's a reason I'm doing this, and I'm going to change something, but I want you to see it. All right, I just changed in here all instances of MO to Missouri. Okay, does that matter? Well, you know, people could misspell it or whatever, and that could be problematic. So what if I added another table here? And I'm not going to put all 50 in here, but what if I added a table called states? And I started with, I don't even know what's first. Is it Arkansas? So I could put AK, Arkansas, in fact, that's AR, I think. I think AK is Alaska. And you get the idea. I could do this all the way down to the bottom where I'd have like WV, for West Virginia. I could have WI for Wisconsin, etc. Hopefully you get the idea. So I'm just going to put here ... All right, meaning that I'd have to fill in the other 46 states. Now, what's the advantage of doing this? It's twofold. Number one, now I can go back to here, and I can go back, and where I just did this, I can now replace all instances of Missouri with MO. All right, well, I guess this one I can't, but let's do it manually. There we go. And it's a lot less typing. It's a lot less problematic. Okay, you'll see there's still a lot of repetition here. Could I put in Wentzville? Well, would I want another table called cities? That might be so voluminous when you think of how many cities there are in the United States, for example, that it might not be worthwhile. But what I'm trying to show you here is we've got in here, we have two tables, three tables, a family table, a friends table, and a states table. All right. But what we're going to do is in this one right here, this isn't going to be state anymore. We're going to call this state code. All right. So this is the setup of both our family table and our friends table. However, when we go into our states table, we're going to have, and let's change these. So we'll have this will be a family ID, and we'll copy this down. And this will be a friend ID. And for states, we'll have a state ID, and then we'll have a state name. All right? Why am I telling you this? Why do you even care? In fact, this is wrong. What I just showed you is wrong. This is not going to be set up like this. We're going to have three fields in here. All right, we will have a state ID, so that'll be 1, that'll be 2, ... and I don't know what the last ones in here are. I don't even know. Let's just say that this is the 49th state and they're the 50th state. Oh, it's TUVWX. I don't know. Am I missing something? Probably I'm missing one or more states. It doesn't matter. All right. But what I want to add here is no, not the state code. I want to add the state ID. So we've got, let's see, let's change this. So under states, we'll have state ID, which is 1, 2, all the way to 50. We'll have state, we'll call it ABBR for state abbreviation. Okay. So that's the abbreviation for Alaska, Arkansas, West Virginia, Wisconsin, etc. So we're going to change that to state abbreviation. Now that we have, what we did was we took a field from this table and we put it into this table. Now this isn't a great example. In fact, it's kind of a stupid example. But when you are working with a foreign key, as it says, it's establishing relationships, and I didn't do a good job because I didn't use the primary key. Okay, now none of my kids are in school right now, but let's assume they all were. Okay. All right, so let's say in here, I also put down something like the name of a school or the ID for a school. And then I had another table over here that was called schools. And I had a school ID and then just a school name. All right. And let's say that I took that school ID and I put that into all of these and into all of these. When you take the primary key of one table, so that'd be the primary key, all right? That would be the primary key, that would be the primary key, and that would be the primary key. When you take the primary key of one table and add it as a field into another table, you are then creating what is known as a foreign key. You'll see examples of this as we go on. All right. The next thing in here are ERDs. An ERD, as it says, is it's an entity relationship diagram. And it shows the relationship between tables. And these relationships between tables are typically one of three. All right. They're either all right, what the heck does this mean? They're either one-to-one, or they're one-to-many, or they're many-to-many. Okay? This is the ideal. This is what you want. As much as possible, you want as many of your relationships, ideally all of them, to be one-to-many. That means that for every one record in one table, it goes to many in another table. What does that mean? All right. Let's say we had two tables in here as an example. Let's say we had a customers table and an orders table. All right. Ideally, every one customer would place many orders. That's what you want. So what about these other two here? All right. Well, for lack of better words, this is typically never mandatory. Let's assume that I created a table. All right, and I put in here, let's just say I'll have employee ID, first name, middle initial, last name, address, city, state, zip, phone. All right, let's say we'll put it as cell phone. Now I'm running out of room, so I'm going to go on the next line here. All right, and now I'm going to say, so I've got the employee ID. Let's say department, salary, work phone, work email. Now there's nothing wrong with creating this, and we're going to call this here employees. There's nothing wrong with creating something like this. It's totally fine. However, what if I did this? What if I change this to employees? We'll call this one employees work info, and we'll create another one that we'll call employees personal info. All right, I'm going to grab everything from here, and I'm going to put this, well, I'm going to move that down, so give me a second here. Now I've got something called employee work info. It's got an employee ID, first name, middle initial, last name, address, city, state, zip, and cell phone. Okay, that's all personal information about that employee. Now, in the personal info, I'm going to keep in there the employee ID, but I'm going to grab everything from here. So when you do this, when you take a single table and you split it into multiple tables so that ideally it'll be easier for people to understand, that's a one-to-one relationship, because every one employee would have information in both tables. So that is a one-to-one relationship. So typically when you create a one-to-one relationship like that, when you do that, again, not mandatory, you do it because it's a little easier to work with. All right, for the one-to-many, we had customers and orders. And as I said, every one customer has 0 or more orders. Now, why 0? What if they're a brand new customer? They haven't ordered anything yet. But you'll have at least one field in both the customers table and the orders table. Probably what you'll do is you will take customers, the customer ID field, and you'll add it into your orders table. And in fact, guess what? There might be even more than that, because orders might be broken up into, for example, order details. All right, we're going to look at all this stuff as we go on. The hardest one to deal with in relational database management systems is many-to-many. That's when there's no fields in common between the two tables. So typically what you do, you create a third table, usually called a join or a junction table, with the primary keys of the other two tables as the what's called a concatenated primary key of the third table. Okay, now I don't expect every bit of this to make sense. All right, but I'm hoping that it'll start to click as we go on. All right, now what you typically want to do in an ERD is you want to show these relationships. So you've got the relationship between the tables and whether or not the relationship is a one-to-one, a one-to-many, or a many-to-many. All right, now ideally what you'd like to do, in an ideal world, what you would like to do is to organize your data within your tables in the best way possible. All right? There is a whole thing on doing this that's referred to as normalization. As you can see right there, the idea behind normalization is that it reduces redundancy and it maintains data integrity. What that means is you want to make sure that each piece of information is stored as few times as possible in the database. Now it says common normalization forms are first normal form, also known as 1NF, second normal form, which is 2NF, and third normal form, which is 3NF. It actually goes to about 7NF, which virtually never happens, and there's a few other ones in there, like voice cod, normal form, etc. Now, for some reason, this isn't showing on here, but it's okay. We're going to look at data models, so you don't have to worry about it. All right? All right. When reading data from tables, it's essential to understand the structure of the table. What is the structure? What the hell does that mean? Well, if we look at what we had in here, let's go back to our simple examples. You'll notice that every field in here, except the ID and the zip code, they're in double quotes, meaning that they're string fields. Now, I could have made the zip code a string field also, but I didn't. This is total numeric, as is this. All right? What I'm telling you is each field has to have a name, it has to have a data type, and sometimes, depending on the type of field it is, a size. And when they come in here and they talk about reading table data, that's what's important. All right, this common table naming conventions, guess what? I'm showing you one right now. And what do I mean by that? Well, if you look at my examples, you'll notice, for example, first name, it's all in lowercase, except when I start another word, okay, that's an uppercase. That's called, what is that? Is that Pascal? I don't even remember. I think that's camel case. All right. Now, in the rest of this article here, it says, for further reading, check these out. I haven't looked at these, but here's mastering the art of queries. All right, how you do queries. This is what you're going to learn to do if you keep watching. Master the art of query validation to make sure that your query is set up correctly. And finally, more on normalization. And I think that as a first blush or a first run at this, this is okay for right now. I'm going to stop right here. When we come back, I'm going to go over the second article, what is RDBMS, how it works, and we're going to look at some examples in here. They probably won't totally make sense, and that is totally okay. After we do this, then we're going to start to bring this around, and I'm going to take this very slowly. I may make up to 10 different lectures in here. I don't know. Might be more, might be less. But when we start, we're going to start by creating, we're not going to worry about object orientation or anything. We're just going to worry about how to bring data in. Because one thing that I meant to mention earlier and forgot to is when you talk about saving data in files or saving data in databases, you'll notice that with both I use the word saving. Until we got to files, our data never persisted. So in other words, our data never was there after we did the program run, we did the next run. Boom, it was gone. All right. So like I said, I'm up to about 50 minutes. I think that's a good stopping place here. We'll come in here and we'll either look at this example and or I'll make another one. We'll see how that goes. Okay. All right, I hope you're enjoying this, and I hope to see you in the next lecture. Thanks.